Hello everyone. In this video, we'll be looking at the product mix problem. The product mix problem is a very common problem. This is similar to the chairs and tables problem that we did earlier in the semester, and we did many examples of product mix problem. This is slightly more involved in the sense that instead of 2 variables, it has 4 variables. Right? So let's quickly talk about about this problem. So you're saying that Floataway Tours has $420,000 to spend, so it can purchase new rental boats for hire during the summer. The boats can be purchased from 2 different manufacturers, Sleek Boat and Racer. And you have to purchase at least 50 boats from Sleek Boat, and you have to purchase at least 50 boats in total, and you would like to purchase the same number from Sleek Boat as Racer to maintain good relationship between the two companies. At the same time, Floataway Tours wishes to have a total seating capacity of at least 200. So the maximum seating capacity it has to be at least 200. And you want to formulate this problem as a linear programming problem and solve it. Now, it's not very clear what the objective should be here, but given that there is a budget that is given for the amount of money that you can spend, I think the objective, you can fairly assume that the objective is to maximize the expected daily profit. Right? Okay, so let's set up this problem. Okay. Right, so let's begin with the decision variables first. Now in this problem, there'll be 4 decision variables because you're buying 4 types of boats. Now, the one of the traps to fall into would be to assume that there are only 2 decision variables because you're buying from 2 different companies, which is Sleek Boat and Racer, but you are buying 2 different kinds of boats from each of them. So you have to keep track of which kind of boat you're buying. So in total, there are 4 decision variables here. So I'm just going to call them Speedhawk, Silverbird, Catman, and Classy. So Speedhawk is the number of Speedhawk boats purchased, right? So number of Silverbird, number of Catman, and number of Classy boats purchased. So these are the 4 types of boats, and the decision variable will be the number of each of the boats purchased. And the objective here is to maximize the expected daily profit. And the expected daily profit values are given here. So you make $70 of profit, expected daily profit from each Speedhawk boat, plus $80 times the number of Silverbird boats, plus $50 times the number of Catman boats, plus $110 times the number of Classy boats. So these are the total. This is the maximum, or not the max. This is the So this is the objective function, and you want to maximize this objective function, which is to maximize the expected daily profit. Right? Let's write the constraints. So what are the constraints here? The first constraint obviously is the budget constraint. So you cannot spend more than $420,000, which is what's available. So it's $6,000 times the number of Speedhawk boats, plus $7,000 times the number of Silverbird, plus $5,000 times the number of Catmans, and $9,000 times the number of Classy boats. So these are the total this is the total amount of money spent buying all the boats that you want to buy, and this cannot exceed $420,000. Right? That's the first constraint. The second constraint is you have to buy from these 2 manufacturers, and you want to purchase at least 50 boats in total. So let's buy the total number of boats in total is 50. So there'll be Speedhawk plus Silverbird plus Catman plus Classy. The total number of boats has to be at least 50, right? That's something to keep in mind. And you also say that you would like to purchase the same number of boats from both of these manufacturers. The total number of boats bought from the first manufacturer is SH plus SB. So that's the number of boats purchased from Sleekboat. The number of boats purchased from Racer is equal to should be equal to the number of boats purchased from Racer, which is CA plus CL. Total number of boats purchased from Sleekboat should be equal to the number of boats purchased from Racer. Right. Now, of course, I'm going to rewrite this constraint. So I like all my decision variables on the left-hand side plus SB minus CA minus CL equal to 0, right? CA and CL, just move them to the other side of the equation and you get that constraint. Now, apart from that, the only other constraint is the total seating capacity has to be at least 200. So 3, 5, 6. So you want to have the seating capacity to be at least 200. So let's write that constraint. 6, so 3 times number of Speedhawks, 5 times the number of Silverbirds, 2 times the number of Catmans, plus 6 times the number of Classies. That's the total number of seats that you have. This has to be at least 200. Okay. There you go. Apart from this, obviously you have non-negativity and integer constraints. In this case, you cannot have half a boat, but as usual, the numbers will turn out to be integers anyway. So let's put this into the solver and solve it. Opening up solver. This is the product mix problem. 4 decision variables here. I'm going to make this much bigger. Okay. So Speedhawk, Silverbird, Catman, and Classy. Decision variable. Oh, of course, left hand side and right hand side. Right, so these are my 4 decision variables right here. The objective is to maximize the expected daily profit, and the objective values are right here. There you go. So objective values are right here. So it's $70 per Speedhawk boat, $80 per Silverbird boat, $50 per Catman boat, and $110 per Classy boat. So that's the total profit that you're going to make per day. Let's write the constraints next. The first constraint is the budget constraint. $6,000 times the number of Speedhawk boats, $7,000 times the number of Silverbird boats, $5,000 times the number of Catman boats, and $9,000 times the number of Classy boats. Has to be less than or equal to the budget, which is $420,000. Right. Next, you have to buy at least 50 boats in total. Total number of boats has to be at least 50. And then you have to buy the same number from both companies. So SH plus SB minus CA minus CL is equal to 0. Right? That's this constraint. SH plus SB minus CA minus CL is equal to 0. And finally, we have the total number of seats constraint. So actually, let me insert a row here. I messed that up. Why? Because I should write the seats constraints first, because seats is a greater than or equal to constraint, so minimum seats. Right? And so the seats constraint is 3 times number of Speedhawk, 5 times the number of Silverbird, 2 times the number of Catman, 6 times the number of Classy, right? 3526, 3526. So this has to be at least 200. See, so like I like to cluster similar constraints together, so I'm going to write them together. That's the reason why I had a insert a row, right? So these are all my constraints. First, let's write the sum product formula, coefficients, comma, the decision variables, which are absolute references. And there you go. So this is how you input the data. Now let's put it into solver and solve it. The objective is to maximize the total expected daily profits. I'm going to leave it on maximize. The changing variable cells are these 4 cells right here. Right? So that is B2 to E2. So those are the 4 cells. Those are the 4 decision variables that we have. Change margin LP. And I add the first constraint that the left hand side has to be less than or equal to the right hand side. So that's F6 is less than H6, F6 is less than H6, done. Right. Now let's write the 2 greater than or equal to constraints. So F7 and F8 have to be greater than or equal to H7 and H8. And finally the equal to constraint, where we say that the 2 have to have the same number of boards bought from them. So you say that F9 should be equal to H9. F9 is equal to H9. Those are all the constraints. So we have the non-negativity constraints. We don't explicitly have the integer constraints, but as I keep saying, the problem will turn out to be an integer anyway. Solution will turn out to be an integer anyway. And there you go. So the final solution is that you have to buy 28 Speedhawk boards and 28 Class C boards. You're not buying any silver boards. You're not buying any Catman boards. Now you'll use up all the $420,000 that's available for doing this. You will buy 56 boards when you wanted a minimum of 50 boards. And the number of seats you'll have available is 252. When you need only 200. So you're definitely buying way more than what's necessary, but this way you maximize the expected daily profit as long as the expected daily profit are these numbers, right? So that's something to keep in mind. And yeah, so that finishes the solution for this problem.